So hello students, I hope you all are doing well. So today we've come up with a question related to the continuous charge distribution. Okay, let us read the question and try to understand it. It is said a charged spherical conductor has a surface density of 0.7 coulomb per meter square. Alright, charged spherical conductor, even though the conductor is spherical, the surface, the charge distribution is on the surface, you see, has a surface density of 0.7 coulomb per meter square. When its charge is increased by 0.44 coulomb, the charge density on the surface changes by 0.14 coulomb per meter square. Now to find out the radius of the sphere and the initial charge on it. Alright, radius of the sphere and initial charge on it. Okay, so what happens here? The surface charge density is already 0.7 coulomb per meter square. Okay, when you are increasing the charge, that means you are adding some more charge on the surface. Okay, by how much? By 0.44 coulomb. Alright, so that means of course there is a change in the surface charge density also. Okay, the charge density or the surface charge density increases by or changes by 0.14 coulomb per meter square. Right, so you have to find out radius r and initial charge on it q. Alright, we have to find out radius of the sphere and what was the initial charge on it before charge was increased. Clear? Now since it is said surface charge density, we can write that we know surface charge density is given by what? Sigma. Okay, and what is surface charge density? Charge per unit area, right? Density that is for a surface is charge per unit area, isn't it? Sigma is, you say, charge per unit area. Alright, so we can write it as q upon 4 pi r square. Why 4 pi r square? Surface area of a spherical conductor, of a sphere. So what is the surface area of a sphere? 4 pi r square. Got it? Alright, hope you understood. So our first case, in our first case it is said the surface charge density is 0.7 coulomb per meter square. So surface charge density means sigma, that is in our first case 0.7 is given. Alright, and on the right hand side we apply the formula 4 pi r square, q upon 4 pi r square. Alright, let us take it as equation 1. Clear? Now in second case, okay, in the second case it is said the charge has been increased by 0.44 coulomb and the surface charge density changes by 0.4 coulomb per meter square. Surface charge density changes. So in the second case it will be 0.7 was already there. Upon addition of 0.44 coulomb, alright, the surface charge density increased by 0.14 coulomb per meter square. So we have to add 0.14 to 0.17. So what will happen on the right hand side? It was q upon 4 pi r square. Now it will be q plus 0.44 upon 4 pi r square. In second case what we can write? Since already 0.7 coulomb per meter square charge was there and another 0.14 coulomb per meter square charges increased because of the addition of more charges. Alright, it will become q plus, okay. Why we are adding 0.44? Because q is the previous charge and 0.44 is the new charge that has been added to the previous charge, 4 pi r square. Alright, now what is this? 0.7 plus 0.14 is 0.84. Alright, and this is q plus 0.44 upon 4 pi r square. Clear? So let us write it as equation 2. Hope you have understood. This is very simple. In the first case, we will just consider before adding more charges to it. That was only q upon 4 pi r square, and on the left hand side we have surface charge density 0.7. Alright, but after addition of more charges, q becomes q plus 0.44, and how much did the surface charge density increase by? 0.14. It increased by 0.14. So 0.7 previously and 0.14 now. Alright, so together it becomes 0.84. Alright, okay. Now what we can do is we will divide equation 2 by equation 1. Alright, I will erase this part. Okay, let's say dividing equation 2 by equation 1. Okay, what do we get? Equation 2 by 1, that means equation 2 will be on the top. That is, what is equation 2? 0.84 what is equation 1 on the left hand side? 0.7. Alright, excuse me. Okay, what is equation 2? Q plus 0.44 upon 4 pi r square divided by, what is equation 1? Q upon 4 pi r square. Alright, so we can cancel this to 4 pi r square, 4 pi r square, right? So now we have, say, 0.84 q plus 0.44 upon q. Okay, and to do it in a most simple way, what we can do? Cross multiplication. Clear? Let us do cross multiplication. So I'll erase this side. I hope you all have understood and you've written as well. Okay. Okay, I'm doing it here. So what happens? Cross multiplication, q into 0.84, q into 0.84. Alright, and on the right hand side 0.7 multiplied with this q plus 0.44. Alright, so we have q into 0.84. Alright, or let us just write it directly like 0.84 q. Okay, 0.84 q. Now 0.7 into q is 0.7 q. Okay, plus 0.7 into 0.44 would give you 0.308. All right. Okay. For verification, you can do your own calculation on the rough hand side somewhere in your copy. Clear? So what happens? See, like terms q and q, 0.7 q can come on this side. So 0.84 q minus 0.7 q, you will be left with 0.308 on the other side. So what is 0.84 minus 0.7? 0.14 Q. Okay, and here 0.308. So what we can do here, 0.308 upon 0.14. Alright, how much will you get? Let me just write it a little small, entire everything, because I will not have space otherwise. Okay, so this is 0.14 Q equals 0.308. Alright, so we are left with Q equals 0.308 upon 0.14. If you are if you calculate and if you are good in quick calculation, your answer will come out to be 2.2 coulomb, because we are finding out charge 2.2 coulomb. Let me write the 2 properly, just a second. Okay, this is your initial charge. Okay, Q. I hope you all have understood. We've done with very easy calculations. Okay. Now what is left to find out? Radius of the sphere, right? What did we find out just now? Initial charge. Therefore, initial charge Q is 2.2 coulomb. Alright. Now, what was equation 1? What was equation 1? Equation 1 was 0.7 equals Q upon 4 pi r square, right? So, you see, from here we can find out R, because we have already found out Q. Clear? We have already found out Q. So, what changes can we make here? From equation 1, okay, can we write like this? 0.7 into 4 pi r square, cross multiplication, equals Q. Now we need to find out R, right? So keep R square here and all other things will become denominator. Yes or no? Everything else will become denominator here, right? 0.7 into 4 pi, R square is on the left hand side already. into 4 pi. Clear? Now I am erasing that side. This part I hope you all have written and understood also. So what can we write here? If you remove square from R, what will you get? Root over here. So the entire Q upon 0.7 into 4 pi will come under square root. Yes or no? What was the value of Q? Q is 2.2, right? This is 0.7 into 4 pi, that is 4 into 22 upon 7. Yes or no? So now what we can write further? if you reverse the 22 by 7, what will happen? I mean 2.2 into 7 will become numerator, and in the denominator you will have 0.7, okay, into 4 into 22. Clear? Hope you all have understood this up to this. Please note it down, go through it, really easy. Now it's basic mathematics that you have to apply here. Clear? So I'm erasing this part, the left hand side, okay. Follow from here what happens. Basic mathematics I'm going to do here, okay. It's very simple. Just a second. See, 2.2 into 10 is 22, alright, or let's just remove the points from the numerator and the denominator. 2.2 became 22, and 0.7, if I make it 7, what will happen? 0.7 after point 1 digit, so in the numerator I will multiply 10, 1 0, okay, and 2.2 after point there is only 1 digit, so 7 into 4 into 22 into 10, because from 2.2 I have removed the point, okay, and after point there is only, it is only one decimal place, right, so another 10 here. So what happens here? 22 22 cancel, right? Now 10 10 cancel, 7 and 7 cancel. Clear? What do we have on the numerator? Everything has been cancelled, so you have 1. Denominator 4, okay. Square root of 1 by 4 is, square root of 1 is 1 only, square root of 4 is 2, so you have 0.5. So 0.5 meters is your radius. Radius r is equals to 0.5 meters. Okay, I hope you all have understood. Okay, interesting question. I hope you all have understood this. Okay, take your time, note it down. It is 64 drops of radius 0.02 meters and each carrying a charge of 0.5 microcoulomb, or let's say 5 microcoulomb. 0.5 would be too small, okay. 5 microcoulomb are combined to form a bigger drop. Combined to form a bigger drop. Find how the surface density of electrification will change if no charge is lost. Okay, understand the question, what it is said here. Okay. 64 drops of radius 0.2 meters, 0.02 meters, and each carrying a charge of 5 microcoulomb. Alright, each charge is composed of 5 microcoulomb, right? Each charge is of 5 microcoulomb and 0.02 meter radius. Okay, now such 64 charges are combined together, okay, to form a bigger drop. Small such drops of 5 microcoulomb charge and 0.02 meter radius have been combined together to form a bigger spherical charge. Okay, so how many such small charges have been combined? 64. Okay, in order to form a bigger drop. All right, now find how the surface density of electrification will change if no charge is lost. So say this is each small charge, okay, so each small drop having a charge of 5 microcoulomb. Clear? Now when you add 64 such charges, when you combine 64 such charges, you will get a bigger drop. Okay, now what is the change in the surface density? Electrification means what is the change in electric charge on its surface when it becomes bigger, a big drop. Okay, and no charge is lost means when you are combining all these small 64 drops and making a bigger one, not even a single charge is lost. Okay, all the charges are there composed on the surface. All right, now you have to see what is the ratio, change in ratio. All right, if this is 1 is to how much will this be? How much it has changed, by what ratio it has changed? Clear? So let's try to do it. Volume of each small drop. So since we are talking about a sphere, what is this volume of a sphere? 4/3 pi r cube, right? Four by 3 pi r cube. Now 4/3, all right, pi, and what is the radius of each small drop? 0.02. So 0.02 cube, okay, say meter cube. All right, so in such a way volume of each small drop, or one small drop is this much, volume of 64 small drops will be into 64 multiplied by 64, right? So with each volume, with the volume of each small drop, you have to multiply 64. All right. Now what happened? Try to understand here on the rough side. 64 small drops gives a big drop. Now each small drop has a radius small r. So the big drop, let's say it has a radius big R, capital R. All right. If each small drop has a radius equivalent to small r, when you combine such small drops 64 times or 64 such small drops, you will get a bigger one with a combined radius of say big R. Alright. So what we can write here is let capital R be the radius of the big drop. Or of the bigger drop so formed. Okay, so what is the volume of the bigger drop? Keep this in mind. 4 by 3 pi 0.02 whole cube into 64, right? So can we write here 4 by 3 pi capital R cube is equivalent to this? Yes, because 4 by 3 pi R cube is the volume of the bigger spherical drop. Alright, and its value is this 4 by 3 pi small r cube into 64. After multiplying the value of each drop with 64 only, you are getting the entire volume of the bigger drop or not. Got it? So from here we can cancel 4 by 3 pi, 4 by 3 pi. Alright, and what will we have here? R cube can be written as 0.02 whole cube into 64. Now 64 is what? 4 cube or not? Okay, 64 can be written as 4 cube or not? Got it? So remember, this part is cancelled. 4 by 3 pi, 4 by 3 pi from left hand side and right hand side are cancelled. Clear? Now you have R cube equals 0.02 whole cube into 4 cube. Okay, so further what we can do here, see, cube, right? These two cubes will get cancelled with the cube on R. So capital R can be written as 0.02 into 4 and you will get 0.08 meters. Alright, so what is the radius of the bigger drop? 0.08 meters. What was the radius of the smaller drop? 0.02 meters, right? Now let's go to the second part of the question. Okay, what is the charge on each small drop? Charge on a small drop is 5 microcoulomb. Okay, now microcoulomb means, okay, 1 microcoulomb means 1 into 10 to the power minus 6 coulomb. Micro means 10 to the power minus 6. Okay, so we can write 5 into 10 to the power minus 6 coulomb. Okay, micro means 10 to the power minus 6. So if this is the charge on a small drop, okay, let's say Q, charge on a small drop, let's say Q. Okay, then what will be the surface charge density of the small drop? What will be the surface charge density? Because you have to find out the change in the if no charge is lost. Okay. you have to find out what is the change in the surface density. Okay, so surface charge density of a small drop or each small drop, surface charge density is written as sigma. Okay, and sigma is q upon 4 pi small r square, because we are talking about each small drop. Clear? So what is q? 5 into 10 to the power minus 6. Okay, then 4 pi. What is r? 0.02 square. Clear? What is the unit? Coulomb per meter square. Clear? So what will be the surface charge density of the bigger drop? What is the radius of the bigger drop? 0.08. Okay, keep this in mind. 0.08 is the radius of the bigger drop. Okay, 0.08 meters. So surface charge density of the bigger drop should be, let's say this is sigma 1, smaller drop, sigma 2 will be the bigger drop. Okay, what do we have? Q into 64, bigger drop, upon 4 pi capital R square. Alright, I hope you all are clear up to this part. Okay, till this point you all are clear. It's very simple. Okay, now I have got to erase this part because I have to calculate. Okay, so please make sure that you've understood. Go through it again, write it down. Alright, let's proceed. So what do you have? Sigma 2 q into 64. Q means 5 into 10 to the power minus 6. Remember, we found out, right? Each charge is 5 microcoulomb. So 5 into 10 to the power minus 6 coulomb. Okay, capital R was 0.08 meters. Alright, into 64. Alright, upon, what can we write? 4 pi r square, that means 0.08 whole square coulomb per meter square. Clear? Now what is the ratio? I told you that we have to find out the change in ratio, right? That is, what is sigma 1 is to sigma 2? Sigma 1 is the smaller drop, surface charge density of the smaller drop. Sigma 2 is the, later on what we have, after combination what we have found the bigger drop. Sigma 2 is the surface charge density of the bigger drop. So therefore sigma 1 upon sigma 2, what was sigma 1? If you remember, say what was sigma 1? Q upon, that is Q was 5 into 10 to the power minus 6, right, upon 4 pi 0.02 whole square. This was our value of sigma 1, right? We have to find this. So sigma 1 is 5 into 10 to the power minus 6 upon 4 pi 0.02 whole square. Sigma 2 is, what is sigma 2? 5 into 10 to the power minus 6 into 64, 4 pi 0.08 whole square. Clear? So what we can do here is 5 into 10 to the power minus 6 upon 4 pi 0.02 whole square, and this divide sign, this big divide sign, if you change it to multiplication sign, this big divide sign is changed to multiplication sign, the denominator reverses. Okay, the value in the denominator reverses. That means 4 pi into 0.08 square will become numerator, and 5 into 10 to the power minus 6 into 64 will be going down as the denominator. So 5 into 10 to the power minus 6, 5 into 10 to the power minus 6 can be cancelled. 4 pi can be cancelled. Alright. Excuse me. So what do we have now? We have 0.08 whole square upon 0.02 whole square into 64. Alright. Okay, let us further calculate it. Okay. Let's do it here. What do you have in the numerator? 0.08. In the denominator we have 0.02 whole square into 64, right? Now what is 0.08 whole square? What is 0.08 whole square? Find out. A square is 64. Okay, 0.0064 and 0.0004 when you expand it into 64. Alright. You can do by removing the points also. Okay, let's just write 64. Okay, and here let's just write 4 into 64. Now after point, how many digits were there in the numerator? 4 digits. Alright, so to multiply 10000. Here after point, how many digits were there? 4 digits. 0000. So these two are cancelled. Okay, 64 cancelled. What do you have? 1 upon 4, which can also be written as 1:4. Alright. So therefore sigma 1 is to sigma 2 equals 1:4. Okay, that is the change in electrification. Okay. So the change in electrification is 4 times in the bigger sphere. Clear? I hope you all are clear. Okay. Interesting question once again. Okay, so if you have understood and copied it down, let us move to the next topic today. Alright, small one. So students, I think we have studied about electric dipole, right? We have done electric dipole. Let's just do a quick revision about it. Alright. Okay, quick revision. Electric dipole. Focus on this word di. Di means 2. Okay, so basically the electric dipole means a pair of equal and opposite charges, separated by a small distance. All right. So suppose this is minus q and this is plus q. Okay, and the distance between them. So this is a dipole. Looks big here, but actually dipole is very small. Okay, so anyway, dipole moment, this is another term, dipole moment. All right. A vector, it is a vector quantity, dipole moment, okay. Whose magnitude is either charge times, okay, either charge times the separation between the two opposite charges. So the direction is along the axis from the negative to the positive charge. Okay, so dipole moment's direction is this, negative towards positive charge. All right. And what is this axis here? What is this axis? The line joining the charges. That means there is a separation, right? This separation. Suppose this separation is indicated by a line. So the line joining. Now, dipole moment is actually written as this one, P. Dipole moment is written as small p. Okay. Now P can be written as see what is written here either charge. That means any one of the charge. You can take plus q or minus q, anything. Okay. So this is dipole moment. Either charge. Let's take plus q multiplied by the separation between them, and separation is always 2a between them. All right. So A and A. This is the field. This is the field for minus q. This is up to here is the field for plus q's. Let's say. So this is plus q. So 2a is the separation. 2a is the separation between them. So any one of the charges you take, plus q or minus q multiplied by 2a, will give you the dipole moment. All right. This is very important. Now you have to understand, when we are talking about electric dipole, we are talking about two charges. That means minus q, the field due to minus q will have an influence, will have an effect on plus q. The field produced due to plus q will have an effect on minus q. So is it superposition principle or not? All right. So dipole field actually can be determined by dipole field can be determined by of a point charge. For a point charge we have a formula, right, to find out the field produced by a point charge, because there are 2 point charges, minus q and plus q. So either charge, right, any one charge you can take. So either take minus q or plus q and find its field. Okay. And the principle of superposition, you have to use these two. Principle of superposition. Okay. So you have to use these two, because there are point charges. Any of the point charge we will take, and we will find out what is the field due to that point charge which you have selected, either minus q or plus q. Then what is the effect of superposition? That means the effect of each I mean effect of the field of either one on each other. Okay. Okay, what is the field of effect of the field of minus q on plus q, and what is the effect of the field of plus q on minus q? Clear? So these are the small subtopics, just a quick revision we can say. So the next topic that I will be discussing will be electric field at an axial point. Okay, at an axial point of the dipole. That means if I take a small charge here, test charge here, okay, what is the field due to plus q on the test charge q naught? What is the effect of the field due to minus q on q naught? Okay, that we'll do in the next class. I hope you've understood here till here, and you have a nice day. Keep studying. Okay, stay well. Take care, everyone.